So I've broken this chapter up into two parts, and here on the we're in the second part, and we've made it to page 59, and we've just finished talking about the AC method, and it turns out there's another method similar to the AC. It's called the Lizzie method, and there's a little bit here that you can read on this page, but this page, what it does is it compares the AC to the Lizzie, and so that's what we're going to look at. Real quick, and then we're going to use the Lizzie method on the next page to factor some more trinomials. Okay, so if we compare the two methods, and what we're trying to do is factor this trinomial here, 6x squared minus x minus 12, we see that in both AC and the Lizzie method, we take AC and we multiply them together. So either method, 6 times negative 12, and we get this number, negative 72. Now, in the second step for both methods, we look at the negative 72 and we factor it, okay? And we check to see which pairs of numbers add up to give us the negative 1. So I'm not going to write all the factors of 72, but there are two numbers, a pair of numbers, that multiply to give us negative 72. That would be negative 9 times 8 gives us negative 72, and then when we add the two together, gives us negative 1, and negative 1 is B if you look back up here at the top at the trinomial. And that's the same step that we do in the Lizzie method. So steps 1 and 2 are the same, but then when we move over into step 3 and 4, there are definite differences. Step 3 of the Lizzie method, since we're already familiar with AC method, says that we take the leading coefficient of the trinomial, and the leading coefficient happens to be the coefficient of the x squared term, the 6. And so what we see down here is we've taken the 6 and our two numbers that we found in step 2, negative 9 and 8, and we divide. 1 6 gets divided by negative 9, and the other number 8, and then we take these two fractions and we reduce them, and we get these fractions, 2 and negative 3 and 3/4. Okay, and it turns out that these are the coefficients of our factors. You see that the 2 goes here in front of the x of our first factor, and then the negative 3 is the non-variable factor term of the first factor, so 2x minus 3, and then this other fraction translates into the second factor. The top number 3 goes in front of the x variable, and then we just simply add the bottom number off to the side. And so either way you go, you get the two factors, 2x minus 3, 3x plus 4, 2x minus 3, 3x plus 4. So we'll move on to the next page and try our hand at this new method of factoring. So, example 20, step 1, same for both methods. We multiply A times C, which is 6 and 5, and we get 30. Step 2, we factor 30, and we note that it's a positive 30, so we say 1 and 30, 2 and 15, 3, 10, 5, and 6. This plus sign tells us that the two numbers of each pair are going to have the same sign. So it's going to be plus plus, or it's going to be minus minus. And we go up here and we check our sign, and we say This sign is a plus, the sign of our b, so both numbers are positive. Now, we add them just like we've been doing, and we figure out which pair adds to give us a b. 1 and 31, or I'm sorry, 1 and 30 is 31. 2 and 15 is 17. 3 and 10, 13, and 5 and 6, 11. So 5 and 6 are the numbers that we're looking for. Now we go to step 3, which veers away from the way we originally learned the AC method. We pick out our leading coefficient, okay, lead coefficient, and we're going to write it on the top for two fractions, and our denominators of those two fractions will be 5 and 6. Okay, this one reduces to a 1 over a 1. This one, however, is already in lowest terms. So, step 4, we simply just write out our factors using the numerator and denominator for our coefficients. So 6 goes in front of the x, and then we say plus 5. Over here, we're going to use 1 and 1 and write x plus 1. A 1x plus the 1 from the denominator, and that completes our second factor. If you want to double check it, just simply do the full method. 6x times x is a 6x squared. 6x times 1 is a 6x. 5 times x is a 5x, and then 5 times 1 gives us 5. So we have the first term, we have the last term, and then these middle ones add to give us the 11x of the middle term of the original trinomial. So the Lizzie method checks out. And sometimes with the AC method, to factor by grouping requires a little bit more writing, so some of you may prefer this Lizzie method. So step 1, 8 times 3, 24. Step 2, we factor 24. Okay, the 24 was positive, so each number in the pairs is going to have the same sign, and that sign is going to be negative. Both numbers negative. So minus, 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 minus. Alright. We take our pairs and we add. First pair gives us a negative 25. Second one, a negative 14. Third one, a negative 11. And the last pair, negative 4 and negative 6, gives us that matches our B. So this is our pair of numbers that we need to use in order to factor. And step 3, we pick out our leading coefficient. We write it on the top of two different fractions, and then we write on the bottom our numbers that we found in step 2. We reduce the fractions, each one. We get a 4 and a minus 3, and now we have the coefficients for our factors. One factor, there's our second one, and this fraction translates to a 2x minus 1, and this one translates into our second factor, 4x minus 3. Okay, so if you get a lot of practice with it and you get familiar with factoring your numbers, this Lizzie method can be pretty quick way to factor a trinomial. So we're at 22. One more trinomial using the Lizzie method. A and C, multiply them, we get the number that we need to factor. It's negative, and so we say 1 and 30, 2 and 15, 3 and 10, and let's see, 5 and 6. Since this C is negative, I know that each number in my pairs is going to have a different sign. So I look up here at my B, and it's negative. And so the larger number is negative. Minus, 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 minus. We add the pairs. Two and negative 15 is minus 13. 3 and negative 10 is a negative 7. And then 4 and negative 6 gives me a negative 1. Okay. And unfortunately, let me see, check my numbers here. I don't think we left out any pair of numbers that we could factor 30 with, negative 30. And none of these pan out. None of these pairs give me the negative 4 that I need. So I'll just double check that. It's a negative 4, and nope, none of them match. So we say that this is prime. Okay, this is our a new way to factor a particular type of trinomial, and these particular type trinomials are the result of squaring a binomial. So what do I mean by squaring a binomial? We could write a plus b squared, and that would be the equivalent of a plus b times a plus b. And so with these types of trinomials, you're probably going to see more than one variable in a lot of them. Not necessarily, but you can. And so squaring this binomial, we use the full method. We get an a squared plus an ab first and the outer. And then we turn around and we get another AB term. B times A is the equivalent of A times B. Order doesn't matter when dealing with multiplication. So B times B, we get B squared. So a couple characteristics we can pick out here. This middle term repeats, and we have 2AB. And then these, the first and the last term are perfect square terms. Okay. So, what we're going to do is, in this particular, okay, we reduced it to 3 terms, and so we know this is a perfect square trinomial because we created it by squaring a binomial. Alright. So, let's look down here at 23. And we've already picked out one way that we can identify, or one identifier of a perfect square trinomial, and that is perfect square terms. This is a perfect square, and the square root equals x. 36 is also a perfect square, and the square root of 36 equals 6. Okay, so our first and our last term are perfect squares. How do we check this middle term? Well, what we do is, since we know that when we square a binomial up here, this middle term doubles, we're going to multiply by 2 for double, and we're going to take the square roots that we found, x and 6. Okay, that kind of looks like a b, but it's a 6. And we're going to multiply it all together. Probably not the best way to write that. We could call this a 2x and a 6, but whenever we multiply 2 and 6 together, we get a 12x. And I wrote this up here above because we want to compare it to this middle term that we were given. They don't match. And with that being said, since these middle terms don't match, this is not a perfect square trinomial. Okay. So the middle term is 2 times the 2 square roots of a perfect square trinomial. Okay, these first two I skipped in this class, but just in case in the future I'll teach another one where we don't end up skipping them. I'm going to show you how to do these. Okay, what we do is we first we're told that this, what do we need, what term do we need to place here, because we've got 1, 2, and then a third term here that we don't know what it's going to turn out to be. We're going to have a trinomial, and so we want to make this a perfect square trinomial. So we look up here, and it turns out that r to the 4th is a perfect square, and so we're going to write square root of r to the 4th is r squared. Okay. Now, we know that this middle term is supposed to match 2 times the first square root times the second square root, but we don't know what that is, so I'm just going to put a question mark there. So in other words, this term is going to be some number or variable squared. Okay, now we need a 2 and an r squared in this middle term, so what is this mystery variable or number here on the end? Well, in order for this to be a perfect square trinomial, this has to equal a minus 8r squared t. So what I'm going to do is solve for this question mark. 2r squared, divide both sides, 2r squared, and that is going to knock out the 2r squared on the left, and all I have on the left now is a question mark. And then over here on the right, the r squareds cancel. 8 divides or is divisible by 2, and we get a 4. We get a minus sign, and we are left with a t. And so that tells me that this is the square root, minus 4t is the square root of the third term, that third missing term, in order for this to be a perfect square trinomial. So to actually get what this third term is, we need to square it. So in the blank, I will write minus 4t squared, and that turns out to be a minus 4 squared, which is a 16, and then t squared is just simply t squared. So this is our missing term. How do we factor it? That's what they're wanting us to do with this equal sign off to the side. Well, we know, let me erase all this other stuff. Now that we know what the first and the third terms are, and we know the square roots, square root of this first one was r squared, square root of this one was a minus 4t. Now that we know what the two square roots were, we simply pair them together, put them together and make a binomial, and we put that in parentheses and we square that binomial, because by definition a perfect square trinomial is a binomial squared. So this is the missing term, and this is how we would factor it once we write in that missing term. Okay, so same drill here with 25. We find the square root. Alright, this middle term is going to be a 2 automatically, times the square root that we know, and then times the square root that we don't know. Okay, so we take this, we set it equal to the middle term, and we solve for the question mark. 2 and a 5n. Two and 5n cancel out, and so we see that question mark equals 2 times 5 is a 10, and we're dividing 20, so we get a 2, and then the n's cancel, leaving an m squared. This is our question mark, and so this missing term is 2m squared squared. Okay, so we know our two square roots, 2m squared and 5n. So to construct our factors, we simply write parentheses 2m squared plus 5n, put that in parentheses, and then we put a power of 2 outside the parentheses. Okay, with example 26, I guess first we should check and make sure that they are perfect square trinomials. So this little arrow just simply means I'm taking the first and this last term, and I'm simply figuring out what the square roots of these terms are. Well, the square root of a variable with an exponent, we simply divide the exponent by 2. So this ends up being an x to the 1 power. This ends up being a y to the 1 power. These are our square roots. And this middle term has to match 2 times the first square root times the second square root. And it turns out that they are equal. So this is a perfect square trinomial. Now, if you were just automatically told that, you wouldn't really have to go through all of these steps. So let's pretend that we were just simply told that this is a perfect square trinomial. Well, all we'd have to do in that case is we'd still figure out what the square roots are, x and y. Now that we have our pieces to construct our factor, we simply write them together in a binomial. We check the sign of the middle term, and so we put a plus in between the x and y, and then we square this binomial, and we have factored that trinomial. We're finished. 27, I'll just assume that it is a perfect square trinomial. I'll take my square roots. Square root of 4 is 2. Square root of this variable part is an m squared. 4 divided by 2 is 2. Square root of 9 is 3, and the square root of n squared is n. So as long as this is a perfect square trinomial, then in order to factor it, I simply write 2m squared, 3n as my second term, and then I take the sign of this middle term and I put it in between the two terms. And so this factor squared is how we factor that trinomial. Alright, so we've talked about all the different ways, and I skipped that last page because it's just a summary of the different ways we talked about factoring polynomials in chapter 5. Feel free to read over it yourself, but I'm just going to skip to the end, and we have about 14 polynomials that we want to factor, and some of them may factor in more than one way. I suggest that you sit down, if you want to practice, and try to factor these yourself first before you watch the video, because I'm going to work through these pretty quickly. Okay, this first one. Always consider greatest common factor first, and it turns out that both of these terms are divisible by 3. We get an x squared, and then we get a minus 9. 27 divided by the greatest common factor 3 gives us 9. You should recognize this factor that's left as a difference of squares. So we construct two factors out of this one from the square roots of x squared and 9, which are x and 3. So we place x and 3 in each factor, and then we make one a plus 3 and the other one a minus 3, and so we have factored this one completely. The next one, we can factor out a 7, an x, and a y to the third. If you compare the terms, x is the smallest, a 1 is the smallest exponent of the x variables, 3 is the smallest exponent of the y variable, and the biggest number that divides 7 and 14 is 7. Okay, so we write down our greatest common factor, we put parentheses to the side, and then inside these parentheses we put the remainder, which would be an x squared. 7 divides 7 just gives us a 1, but x to the third divided by x is x squared, y to the fourth divided by y to the third would be a y. 14 divided by 7 is 2, and then x and y to the third completely cancel out when we divide it by our greatest common factor. So this second term of the remainder is simply a minus 2. Here we have a trinomial, and a is not just 1, and there is no greatest common factor. So what we need to do is, I'll put an arrow here. Step 1, write down AC. A times C, 3 times negative 6 equals negative 18. Step 2, factor negative 18. 1, 18, 2, 9, 3, 6. The two numbers are going to have opposite signs because 18 is negative, and that sign of the larger number needs to be negative because the b is negative. We add these. We get negative 17, negative 7, and this matches our b. So I stop there, I take 2 and negative 9, and if I follow the Lizzie method, I write two fractions, 3's on top, my 2 and my 9 on the bottom, and the 9 is negative. 3 and 2 will not reduce, but 3 and negative 9 will reduce to a 1 and a negative 3. And so step 4, I just simply write down my factors using the numerator and denominator as my coefficients. 3x plus 2, and x, 1x, and then a minus 3. 4 is the sum of perfect cubes. So I take the cube root of each of these and I get A and I get 4. So at this point you just have to remember the template. The first factor of the sum of cubes is A, the first root, plus 4, the second root. And I put a plus here because we are dealing with the sum of cubes. The second factor has 1, 2, 3 terms here. First term is the first square root squared. The last term of the trinomial is second square root squared, so 4 squared. And then the middle term is the product of the two. Now, the second sign is the opposite of the first, so minus, and then the third sign is always a plus. And to finish this one, you really want to go back and simplify these squares and write a 16 instead of a 4 squared. Alright, this one we usually avoid situations where we can help it, dealing with a leading term as negative. So what I'm going to do first is take that negative out as a greatest common factor and write x squared plus 6x plus 9. And so I don't have to worry about the minus sign confusing me and slowing me down. And at this point, notice that the leading coefficient is a 1. So all we have to do is consider the 9 and find our m and n. So 1, 9, 3, and 3. And the 9 is positive, so these numbers in each pair are going to have the same sign, and that sign would be the sign of B, plus, 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 plus. Add the pairs, we get 10 and we get 6. And so the second pair matches our B that we have in this trinomial. So our numbers are plus 3 and plus 3. So I write x plus 3 and x plus 3 as my factors. And it turns out that this was a perfect square trinomial because the two factors are identical. So I could write this, I could simplify it and write a minus x plus 3 squared. Here, x squared minus x has a greatest common factor, x. Oh. And if I factor out that x, this first term now becomes an x and the second one a 1. And we are finished. It's as far as you can factor that one. This one, we're going to break it up into two factors if the numbers work out right. So note that this is a trinomial with a leading coefficient of 1. We take c, which is positive, and we write the only way that you can factor 2 is a 1 and a 2. And the b tells me that both of these numbers need to be a negative. And then we add them. Negative 1 plus a negative 2 gives me a negative 3, and that does not match B. So that tells me that this trinomial is prime. We cannot factor it this way. Number 8, leading coefficient's 1, and we have a trinomial, so we'll take 6 and write 1 times 6 and 2 times 3. This was positive, so the numbers are going to have the same signs, and that sign should be a minus. We add, we get a negative 7, and we get a negative 5. This one matches our B, and so we need this minus 2 and 3 to construct our two factors. X and x to multiply and give us our first term, x squared, and then we just put out to the side of each x a -2 and a -3, and we're done. Number 9, we can factor out a u squared, and when we do that we're left with a difference of squares. So this is going to factor as an x squared minus 4 and an x squared plus 4. Okay, x squared is the square root of x to the 4th, 4 is the square root of 16. We have a plus and a minus. But now we can go a step further. This factor is prime. It is the sum of squares. This one, however, is another difference of squares. So now we can write u squared, x squared to the 4th. We can't do nothing with either one of these two. But the other one will break up into two factors, x and a minus 2 and a plus 2. 10, we can factor out a 6 from both the 6 and the 24 and an x to the 3rd. And we are left with a 1 plus, let's see, 6 from 24 is a 4, and x to the 3rd from x to the 5th is an x squared. And this is the 1 is a perfect square, 4 is a perfect square, x squared is a perfect square, but this is the sum of perfect squares. So this is prime and we can't go any further, and so this is how we factor number 10. Number 11, we can factor out of x to the 4th, and that leaves us with a y to the 3rd minus the 27, which is the difference of cubes. So I write x to the 4th, y minus 3. The cubes is our first factor. We have a minus between them. And then our second factor is a trinomial with a y squared as the first term, a 3 squared as the last term, and then a 3 times y as the middle term. The second sign is the opposite of the first, and the last sign is always a plus. Don't leave it like that. There's one last thing that you can do to this, and that is to go ahead and square that 3 and write it as a 9. Number 12, there is no greatest common factor, but we do have a coefficient other than 1 here, so we're going to do either the AC or the Lizzie method. So step 1, we write 2 times -7, and we get a -14. Step 2, we factor -14 as 1 and 14 and a 2 and a 7. Since 14 is negative, these two numbers are going to have opposite signs, and so we look at B and we say B is negative, so the larger number here, it must be negative. We add the numbers of each pair, we get a -13, and then we get a -5, which matches our B. So 2 and -7 are the numbers that we need to factor the trinomial. If we follow the AC method, then we write 2x squared plus 2x minus 7x. We're simply breaking up this minus 5x into these two terms using our numbers that we found. Now we group first two together and the last two together, and we factor by grouping. So out of this first two terms, we take out a 2x and we're left with an x plus 1. Out of the second group, we have a -7, and again we get an x plus 1. So we take out that x plus 1, and whatever's left pieces together our second factor, 2x minus 7. "13 is the difference of squares. The square root is x of the x squared, and the square root of 1 is 1. So we go over to the right and we write out two sets of parentheses for our factors. X and 1 make up the first and the second term of each factor, and then we simply make one a plus 1 and the other one a minus 1. And so finally, number 14, 9, 18, and 8, they have no greatest common factor. This is a leading coefficient of 9, so we have to use the AC or Lizzie method. I'm going to make myself a little bit more room. Start with step 1 and multiply A and C together. We get 72. Step 2, we factor 72, and so we have 1 and 72, 2 and 36, 3 and what do we get? 24. Let's see. Does 4 divided evenly? Yes, we have 1 and 32, so 18. Okay, 72 is not a common number. What are some more divisors? 6 goes into 7 once, and then we have a 12 left, so that would be 1 and 2. 6 times 12, 72. And then what else? We have 7 won't, but 8 and 9 will. Okay. So now what we do is we add each pair, and we say that since 72 was plus, then these numbers in each pair are going to have the same sign, and that sign must be negative. Both negative. So minus, 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 minus on all of our pairs. Which one of these pairs adds to give us a negative 18? That is the negative 6 and the negative 12. So step 3, I'll use the Lizzie method and write a 9 and a 9. And then underneath the 9s, I put the negative 6 and the negative 12 that I found, and I reduce the two fractions. So 3 reduces this one to a 3 and a negative 2, and then 3 reduces this one as well, and we get a 3 and a negative 4. So our last step, we use the fractions to construct our factors: 3x and minus 2 and 3x and minus 4. And so that completes everything in chapter 5. Thanks for watching.